Question. In order for the ball to move upwards, can its velocity, initial velocity, be 0? What do you guys think? Take some time to think about it. Can its initial velocity be 0 if it is going to move upwards? No. In order for the object to go up, its initial velocity must be greater than 0. So in order to go up, initial velocity must be greater than 0. And also, people mistakenly think that at the final position, at this point, when the object reaches the ground, its velocity is 0. So, V final, you can use V final, is not equal to 0. Okay, so sometimes people mistakenly think the final velocity for a falling object is 0 because the object stops once they hit the ground. In physics problems, the final velocity is the speed just before touching the ground. Once it touches the ground, the object is no longer in free fall, right? So when the object is in free fall, the final velocity of the object is not 0. Okay, now let's look at another example. Now let's consider a rock thrown upward from an unknown height, and it reaches a maximum height above the ground and then falls to the ground. So I want you to think about how to draw a motion diagram, including the parts of the motion that are in free fall. So that are in free fall, which means from just after release until the moment just before the rock hit the ground. And you have to neglect the air resistance. So I'm going to consider the ground as the reference point, and also I'm going to take up as positive. Now you start from a particular height level, okay, and let's assume that the initial height is just maybe y0 or like whatever. I have y here, so you have a certain initial height, and then it is moving up. You can see the dot represent the position of the rock at equal time intervals, right? And when it is moving down, you can see again the dot represent the position of the object at equal time intervals. All right. Now let's discuss the acceleration, the sign of the acceleration, the sign of the initial velocity, final velocity, and then time, and then displacement. So the object starts its motion at a certain point above the ground, so it's moving up. And since acceleration due to gravity is downwards, the object is going to slow down while it is moving up. Okay? So it's going to slow down, and then at the maximum height level, Vy is going to be 0. Okay, the y velocity, and it's going to turn around once its velocity becomes 0, and then it's going to speed up until it reaches the ground by the same magnitude. Okay, so this arrow represents the velocity vector. Now let's see the sign of the acceleration. Is it positive, or is it negative, or is it 0? The acceleration is still downwards, and our coordinate system says up is positive. So the acceleration should be a negative. And then initial y velocity. So you can see clearly in the diagram the initial y velocity is up. Okay, so this is the initial y velocity, v naught y is up. So for that reason it is positive. And then final y velocity vy, remember I said it's not 0. So final y velocity is downwards, so it's negative based on our coordinate system. And time, so time is obviously it should be positive. Time is a scalar quantity, and when the object is moving, the time, elapsed time is going to increase. And then the displacement, final y position minus initial y position. So displacement is going to be a, what do you think? Is it positive or negative? This is my reference level. So if you look at the initial y position, it is greater than 0. And final y position is just a 0. Okay. So final y position is 0. Initial y position is greater than 0. So 0 minus y naught, you will end up of getting a negative number. Okay, so let's assume this is just 10 meters initial y position. So final is 0. 0 minus 10 is a 10. 10. It's negative 10. Okay.